Hello, in this video, we are going to take a look at solving the integral of 1 over the square root of x squared minus 4x plus 13. First, when we see a quadratic, one of our first things to look for is, can I easily factor this? Well, 13 has the factors of 1 and 13. There is no way to take 1 and 13 and make that add up to be a -4. So this quadratic is not something we can easily factor. If it were, we may want to explore other integral options, but when we can't easily factor it, we want to move on to looking at a trig sub idea. And to use trig sub, we want to get this into one of our forms, either a squared minus x squared minus a squared, or a squared plus x squared. So I want to take these x terms and turn them into something squared. The way we do that is with the process known as completing the square. And you have probably seen this process before. But as a review, we're going to take our quadratic x squared minus 4x plus 13. We're going to separate off these x terms, the x squared minus 4x, and keep the 13 separate. We are trying to complete the square on the x squared minus 4x. What completing the square there means is I want to turn it into a factorable trinomial that not only is it factorable, but it will factor into x plus or minus something squared. I want to make it so this factors in that specific way. The way we do this is we take the -4, we divide it by 2, and we square it. So take that b term, divide by 2, and square. -4 divided by 2 squared is 4. So I'm going to add 4 into this quadratic. I have now changed this expression, so I want to keep it balanced. So since I just added 4, I'm going to subtract 4 from the 13 to balance it out. Add 4, then subtract 4. 13 minus 4 is 9. And now this x squared minus 4x plus 4 factors nicely into x minus 2 squared. And now this quadratic is what is going to go under our square root, putting us into having one of these three forms. This is equal to the integral 1 over the square root of x minus 2 squared plus 9 dx. We now have the form x squared plus a squared, meaning we have this form, this third form, and we're going to make this substitution x equals a tangent theta. And instead of just the x becoming a tangent theta, the full substitution is going to be x minus 2. The whole thing in that squared position equals 3 tangent theta, because 9 is 3 squared. Dx is going to be the derivative. So the derivative of tangent is secant squared. And we now make this full substitution to get the integral of 3 secant squared theta all over the square root of x minus 2 squared is going to become 3 tangent theta squared. Rewriting with some algebra, we get the square root of 9 times tangent squared theta plus 1. I'm factoring out a 9 that is in both of these terms from a 3 squared and a 9. And now tangent squared theta plus 1 is secant squared theta. So replacing that with the Pythagorean identity, we have the square root of 9 secant squared theta in our denominator. Numerator keeps staying the same, but the square root of 9 is 3, and the square root of secant squared is secant. The 3's cancel, and the secant squared cancels with a secant in the denominator, giving us the integral of secant theta. This is an integral we can do with a u substitution, a fancy u substitution, but we also know it is the natural log of the absolute value of secant theta plus tangent theta. Now, the last step, we have an antiderivative, but it's still in theta. We want to turn it back into x. I'm going to take my substitution and do some rewriting of it. We know if x minus 2 equals 3 tangent theta, x minus 2 all over 3 is tangent theta. So this will become x minus 2 over 3. To find secant, we're going to write out a right triangle, knowing that tangent is opposite over adjacent. So I'm going to put x minus 2 opposite my angle of theta, and 3 adjacent to my angle of theta. And by the Pythagorean identity, or the Pythagorean theorem, this third side, the hypotenuse, is going to be the square root of x minus 2 squared plus 3 squared, or 9. Secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent, meaning secant is the square root of x minus 2 squared plus 9 all over 3. So this piece is going to go in for secant, giving us the natural log of the square root of x minus 2 squared plus 9 all over 3 plus x minus 2 over 3 from tangent plus c. And there is our final answer for the antiderivative of the integral of 1 over the square root x squared minus 4x plus 13 dx.